All right. So hello to the people in the recording. We're going to start here with the handout. So get your handout out. And first, we're going to do this for the rectangle that we need. So I have here a regular piece of paper, folding it in half. And now I need to fold the diagonal of a square, right? So, pick a side, any side, and simply take the short edge and put it on the long edge. You can fold this one slightly. You don't have to fold this one with vigor. You can just simply, just as a reference, because what we're actually looking for is where this fold ends over here. This point is what we're looking for. We don't have to cut into a square. Actually, I think it's preferable if we don't cut into a square because it will give us a bigger rectangle. So it should look like that. We're going to fold it in half once more. And you need to be facing the side that has the top diagonal, the one that's cut off. So I have this little bit of extra. You might have something different, but we're looking for that point. At that point, we're going to fold the line that goes from that point over to the folded middle, right here. So from that point over to here. So I lift. What I do in these cases, I lift my paper, and I'm not really focused on getting that point first. What I'm getting at is that the fold is actually coming from this middle point right there. Oh, wait. I forget that this thing records what I'm looking at, and I had the gallery view. All right. So yeah, at that point, and then I pivot. Well, I call it that. So I make sure that that's, and then I start to pivot. Pivot in such a way that it lands on that point over here. And you can always course correct. If you miss, you can just make sure that it's there. If it's not there, you can just move it a little bit to the side and fold it until you get to where you need to be. It's important to actually have that reference. So, sometimes it helps me to put a little point there with a pencil, but you want it to be as close to where that line is hitting as you can make it. All right, I think I'm satisfied with it. Or am I? Yeah. Good enough. All right. So then you have this. Now, this triangle right here, with this hypotenuse, is a unit, double, and then this is a √5. So what we're going to do is we're going to do a ravadier on this triangle. So in order to do that, we're going to bisect. We're going to take the small edge, the unit edge, and put it on the hypotenuse. Now, it varies the way I approach this, but today we're going to approach this in this manner. We're going to leave this folded in. We're going to unfold, and now fold the other bisection. So now fold the double unit to the hypotenuse as well. And now we're going to combine the folds into what's called the ravadier. So as you can see, they actually have an intersection there. Both of these bisections land there. Usually the way I did it was I marked the point, I unfolded it, and then we marked the perpendicular. But it turns out there's an easier way to do it. So what we want is for both folds to be simultaneous. So what I do is I take the bottom, I start folding with my thumb, and when I reach the intersection, I stop folding, and then I begin to fold the other one as well. And now here, what you want, well, of course, you want it to be simultaneous, but you also want this to land. Notice that I'm squeezing it together. You see that? To make it like a spiky little thing. And then once this is spiky, I set it down like that toward my, what would that be? The bottom? So notice that this flap is not heading over to the top, but rather it's heading toward that point. And notice also that this is spiky. And if you open it up, you can see how from that intersection, there's a line that falls to the corner. And this actually is the bisection. So this is also the diagonal of a square line, because all of these are being bisected. This corner bisected, this corner bisected, and this bisected as well. And with a fold, well, the line we're really looking for is this one. We did all of this just to get this line. That line is what's most important to us at the moment, because it goes from that intersection and goes perpendicularly toward the edge. That's why this is important. So once we have that line, we can unfold. And now we're going to extend this line. So in my case, this is going mountain. So I need to turn it over because valleys are easier to fold. Look, that pencil just slid away. Yep. Yeah. So that line that we marked, and that I'm gonna extend. So that means I'm gonna fold it. You're gonna see how it lands on the edge right there because it's perpendicular, and simply extend it. And because this condition is satisfied, was what I was saying about the faith aspect of it, that this is the fold, so no need to think about it too much, just, and the fold will be there for you. And of course, when it ends, the left, in my case, because this is my right, this is my left, it's also falling on the edge, see? So it's perpendicular. All right, beautiful. So now that we have it on, in my case, my left side, I want to put this same distance over on my right. So how are we going to do that? We're not going to repeat the process. We're not going to do the triangle again. There's an easier way to do it. Simply by folding. You see? We can mirror the distance. So I fold the little flap first. I have that distance. I fold onto it. And there it is underneath. So I simply just fold on top of it. Now, this one, we don't need to fold the whole thing. This one is optional. You can fold it if it makes you feel better, but we don't really need to. What we really need is just this point that touches on the edge. That's all we really need. The whole line is optional. What we really want is just where it hits on the edge. That's all we really need. We just need where that is. So I have here that point, and then I also have it here. Now, the second one we marked, we're going to use as an anchor, I like to call it. So this is going to swing around. And so we're going to get to see something beautiful regarding how this might relate to compass and straight edge. So here's the enigma. Here's the solution. Here's the situation, rather. This distance right here, from this point to this point, is the edge of a pentagon. It's the edge of a pentagon that's like inside of a square, right? So I want to lay it down for you because I think this is one of the more beautiful things that we can do. So it's as though we have as a square. This is what's happening. And over here in the bottom, we have a pentagon edge. And it's the exact pentagon which then hits on the edges of the square and then bounces off and hits at some point. So what's exactly happening is that this edge of the pentagon is the same as it goes toward the edge. Okay, so what are we going to do? We're going to take this and we're going to put it onto the edge. See? So I make sure that the fold is coming in from that point, from the first one. And then I make sure that the other point, the second one, lands on the edge. And we fold that. So you can see there how the second point I marked is on the edge there. And the fold is coming from the first. So the beautiful thing about this fold is that if we have sad pentagon, this fold is going exactly through the center of the pentagon, right? So if we have a pentagon and the line that goes through the center like that, what's this angle? So we have that the internal angle formula is n minus 2 times pi over n, right? So in this case, it's 5. So we substitute n by 5. So it's going to be n 5 minus 2, that's 3. So that's 3 pi over 5. That's the whole angle. That's this one. But then this one is half, right? Because it's cutting it exactly in half. And so we have this angle cut in half. So what we do is we multiply this by a half. So 3 pi over 5 times 1 over 2. So 3 pi over 5 times 1 over 2, and that's equal to 3 pi over 10. And this is what we were looking for. So we've constructed the diagonal that we needed. And so where this fold hits on the edge, we're going to cut it. We're going to fold a perpendicular line. So we can leave this folded in. What I do is I turn it over, but you don't really have to. You can leave it on this side because there's no overlap here. But from this point, what you do is you bring it down and you make sure that this over here lands on the, it might be worth going onto the side because the fold doesn't get in the way. So I turn it over so that the fold doesn't get in the way. So I make sure that here the fold is happening. That's exactly where the fold is hitting on my edge. And over on this right side for me, I make sure that it lands on the edge. I forget which number axiom this is, but this is one of the axioms where it says that if a fold lands on itself, the resulting fold will be perpendicular to that line. So because we're making the fold land on the edge, this fold will be perpendicular to the edge. So we're making a little rectangle. So we can unfold the first one we did. And then we can fold the whole line that we had, this one. And you can turn it over now. And so this rectangle is the rectangle that we need. Because inside of this, we're going to get the rhomb. But we need to cut this out. So we need to cut these two folds, the fold that is on the outside and the fold that's on the top, in order to extract it. So this is why I prefer not to cut the square from this. Because if we had a square, you can see how the square hits here. So the square will result in a smaller rectangle than this bigger one that we could get. So we're going to cut this line and this line. The way I cut things is with folds. I don't use knives. Sometimes I use knives for the cutouts. But for these kinds of constructions, I don't use knives. I think that they can actually be more inaccurate. So here's what I do. I have a fold. In this case, it's mounted. I'm going to fold it now the opposite state. So if it's mountain, the opposite is going to be a valley. So if this one wants to go mountain, now I'm going to fold the valley like that. And then I'm going to really drive it in with my nail. So I put my nail like that with my thumb and my forefinger, and I just really drive it in. Do the same thing for the other fold. It's also a mountain. I change it into a valley and I really drive it in with the nail. And that's not enough. It might be enough for you, but it's not enough for me. So what I do is I open it, I turn it over, and I turn that mountain into a valley once more, but on the other side. And I really drive it in with the nail. The more times you do this, the weaker the fold becomes. And the weaker it becomes, the less resistance it will put once we rip it. When I was a kid, I used to lick it. I used to hold it like that and I would just slide my tongue and rip it out. With time, I learned that that actually weakens the fibers a little bit more than you would like. Like it sort of damages the structure a little bit. And it might rip out more than you might want. So I now do this method. It was taught to me by this paper artisan in Veracruz. He was selling origami paper boxes in the street. And he taught me how to play Go as well. He told me that in order to learn how to play Go, you need to play 100 games. Until you play your 100th and first game, that's your first game of Go. I don't know if I've played 100 yet. So long ago. I'm more a chess guy now. By the way, chess is getting a super mega boom. It's like so popular right now with the kids. They're watching it on Twitch. I think it was the most watched like thing on Twitch like 3 days ago. 100,000 people watching a chess game. Isn't that amazing? So, okay, we have this rectangle now. The 3 pi over 10 rectangle. Beautiful, beautiful thing. So from this rectangle, we're gonna extract the rhomb. Now, you might want to not discard completely this thing, because this thing that we ripped out of it is gonna help us if we wanted to make another one. Right, we can take out the same piece of paper, something just similar like that, and we can use this to mark that point and that point, right? And so with ease, we can extract another one like it using this, and a cleaner one at that too, without all these construction lines. So, you know, just food for thought. Yeah, no, actually, I've been playing chess for like years, right? And then the Queen's Gambit came out, and my ELO rating just like dropped because so many more people were playing. So, you know, I wasn't as good as so many more people. So just my rating really dropped. I had to get more into theory and like learn more just to get back to where I was, and I still haven't. Anyway, so here's how you get the rhomb. We have this rectangle. We fold on the diagonal, like so. And now you might see here some negative space, I like to call it. So from this point of intersection, we're going to fold the line from there to the corner, using the edge on the back as a reference, using this as a reference. So you have it like that, and we're going to use the back edge there as a reference. So fold it to where it lands on the edge right here. We can do more fancy angle maths and like find why this works, but we're gonna not do that right now. But it's a fun little exercise if you want to try it out. So we do this on one side, we turn it over and do it for the other side as well, using the edge as a reference. Now, once you fold this, it's optional to cut it out. You don't have to cut it out, but it's an option. If you choose not to cut it out, your model will be inside of a rectangle. So it might look tessellatable, but it's actually going to be a little bit less tessellatable than you would imagine. I don't know why that is, but it's an interesting thing to think about. And there's our rhomb. Now, because of the instructions, I'm going to cut out the excess, but you can actually pretend that the excess is not there. You can just leave it folded the whole time we're folding. That's an option. So take that into account. I'm going to cut it out because of the instructions, but you don't have to. You can leave it in and it's going to print the folds onto it just as well. I just want to really follow the instructions on the handout. And we're basing our construction off of this. So what are you going to do? All right. So what's beautiful about this thing is how much it relates to the pentagon. And one of the more beautiful things about the pentagon is its self-similarity. You can find infinite amount of pentagons, infinite amount of ways inside of itself. And that's something that actually called the attention of Pythagoras. And it is sort of the reason why he had the pentagram tattooed on his followers, or rather the followers tattooed the pentagram on themselves, on their hands, which I think is pretty punk rock and cool. The first cults to ever exist, they would say that God is numbers and things like that, right? It also drown people if you reveal their secrets. It is said that somebody got drowned for revealing the dodecahedron, because it was a secret. Okay, so we have the rhomb. So now you can pull up your instructions, because now we're going to follow those. And, you know, essentially, I'm going to reveal the same kind of instructions as the handout, but you can follow along with me just the same. Without it. And maybe I should pull them up, because then I get crazy and do things. Let me see. There we go. Okay. All right, so first couple steps involves us just folding the bisectors on the corners. So we already have this one. So now we fold the other one that goes like that, a horizontal and vertical. Now, depending on your construction, some inaccuracies might pop up, and there are ways to like correct those, etc. But it's interesting to think where a mistake could have happened. And there's also ways to rectify that we're actually constructing this angle instead of just like doing it and saying like, we got it. There are ways to actually verify that we did get it, but we avoided those in the moment. But pretty much it involves us just completely going in to see that we got a pentagon and then. But yeah, so an inaccuracy in the triangle construction will result in an accuracy in the rhomb. So there you go. All right, so first two verticals. What I like to do for the bisections is actually have them be opposite of this state. So I didn't include that in the instructions, but for this case, I like to turn it over. Because now this line is a mountain, so the bisector wanted to be in a valley. These, in order for my sequence to be mountain valley. That's something I like to have, just a little rhyme to this. And actually, if you keep an eye out, you're going to see several pentagons appear all over this thing as we fold it along. So first those two. We unfold and we do the other two. So remember how this corner, it's on the first page of the handout, but we have two angles on this thing. We have the 3 pi over 5 angle and the 2 pi over 5 angle. So notice how we have already split this into into halves, right? So this like this, if this is 2 pi over 5, when you split it in half, then this is pi over 5, and this is pi over 5. So the suggestion is that this is going to be trisected. It's going to be split into 3 equal parts. So it's also very interesting and beautiful how those 3 parts come about. It just so happens that that trisection is on this line. What does that mean? It means I'm going to take the vertex and I'm going to put it on the end of itself, of the fold that we just did, this fold that we just did. Take the vertex and put it on the end. So a super accurate construction will result in a very spiky point there. You can see that I was a little bit off because it has a little something something, but I think it's fine. But a super accurate construction will result in all these things lining up. So there, you can see that this line also falls on itself. Do you see that? And then from here, we take that vertex and we land it on the back of it. So like this and then back. And so as you can see, we now have trisected it. 1, 2, 3.
Yeah. Man. Yeah, no, for sure. Well, if anything, what I said to them is finish off the 15 apartments. So you got 50.
That was Shamina, but I think that was background noise. So Shamina, if you have a question. So we do the same thing now for the other side. Sorry to call you out, Shamina. So same thing on the other side, and 1, 1, 2, and 3. Everybody good so far, by the way? We all getting along? Right on. So, you know, the full thing actually ends up being in 6 parts. Just as much as this 2 ends up being 4 parts, this ends up being 6 parts. 1, 2, 3, 4, 5, and 6. Because each of them now is going to be pi over 10, not pi over 5, because pi over 5 is going to be this one, and pi over 5 is going to be this one. But then half of it, pi over 10. So we did it on this side, and now we do it on the other corner. No problem, Sharmina, no problem at all. Good to have you here, by the way. So for one side. Nope, not for the other. Now there's an infinite amount of Islamic patterns that we can actually solve for and put it inside of this rhomb. This is not the only one, but the one I'm going to teach you is actually quite beautiful in the way that we're going to get like in an origami fashion. That's what I like about this one, but it's not the only one. And I'm going to show you a very obvious one, just going to sort of indicate where it is, but not going to fold it right now. But I'm going to show you where it is if you want to try it out later. Also, the fact is that rhombs have a similar property than rectangles, and that if you cut them on their, on their halves. So if we split this pentagon, this rhomb in half like there, and across like there, we would end up with the same pentagon, same rhomb, right? Just 4 of them, right? So if you wanted to have many of these rhombs, you can just cut this in half like that. So just fold in half, and I have a smaller rhomb. So anyway, okay. So I'm going to change the orientation of these folds in order for these two to be the same. Which two? These two. The closest one to the edge. So that's my edge. And this one is the closest one to it. And so is this one. I want these to be the same state. Now this can wait also. We don't need to do it right now. But just keep that in mind that we need these two to be the same. This is for the step. So we're leading up to the step on step 9. So we want to get to that. I think we're right now on step 8. So what we need is now this line to land over here. These over there. And that's going to be on all 4. So pretty much what I was saying of cutting this thing in half. Actually, no, this is not the half bit, but here. Now, if you were inaccurate, it might happen like it is to me. Like some things are a little bit off because I'm a little bit inaccurate. So what I'm trying to make it so is that this lines up to the edge and that this line also matches up. If they don't, I can like, you know, skimmy it around so that I can get as many intersections on my fold as possible. It doesn't have to be perfect. You just have to have a clear intention. So this is a step 8, I believe. So, you know, just for future reference, can you find 2 pentagons on this thing? Can you find the 2 regular pentagons that are on inside of this? So if you were to inscribe a pentagram inside of those pentagons, you would end up automatically with an assigned pattern. Now, it's not so easy as just putting it inside. You would need to put it in the midpoints of this pentagram. We're not going to do it right now, but just as a little fun fact, that these 5 points that I've indicated are the midpoints of this bigger pentagon. So if you were to inscribe a pentagram inside of those, you would end up with a base for an Islamic pattern. I'm not going to do it right now, but just, you know, food for thought. What we are going to do now is the step 9. So we need to like reduce this thing to like an origami shape. This is where the origami comes into play. So I'm going to fold these into mountains like that. So I like to go for those first. Now, the thing about origami circuits, as I like to call them, is that in order for them to work properly, you need to have everything set up. You can't half-ass it. You can't do one thing on one side and not do it on the other side. You need to have it be, yeah, it needs to make sense. It's going to look a little bit like this. And now I need a mountain that goes from there to this intersection, and this is going to become a valley. It's going to sink like that. We're going to get like a Superman logo, you know. Now on the instructions, we're now on the second page. I avoided some things that were because it's hard to diagram these things. But as you can see, if we lift it, we actually have these like little legs on this thing, which are not included in the diagrams because I guess, I don't know. I could have put them in, but because I'm like a perfectionist and I want the folds to be there, it's just a matter of, yeah, no, it got a little bit crazy for me. So I just avoided it completely and pretended that it's not there. But if you look at the thing in your hands, you're going to see that very much is. So there it is. We had the Superman logo shape. It's not even, right? But it's like a diamond and a regular pentagon. And this is going to be the basis for this thing. So if I open it up, you're actually going to see also the folds happening. It's quite beautiful, no? So what's interesting is that we can also, once we have this set up, we can cut out on there and it'll work. Also worth noting is that this thing is, if we open it up a little bit, you can notice how all the edges are touching the surface of my table. And I can actually like hold these 4 points and like push them. And the whole edge is on the table. What's interesting about that is that I can actually make more of these and then put them side by side with this arrangement. And I'm going to see how, if I had more, this one could match up to here. And I could actually make a little tessellation or corrugation thing happen with this. And I could then sticky tape them and watch it work. Just as a side note. So everybody got their Superman thing? Little diamond. Alrighty. So step 10 is not diagrammed, but you can see an orange line there that indicates a fold. Now we're only going to fold it on one side because I'm sort of pretending that we're going to cut it out. We don't have to cut it out. We can actually just fold everything. That's also going to be work for us. So if you, depending on what you want to do, if you want to cut it out, then only do it on one side. If you just want to fold it, you got to do it on the other side as well. Some of these folds, not all of them. But anyway, this one we can do it on one side for now. This is step 10. So this is just a fold where we just lift this on these two folds connecting. So that, and we then unfold. Now here's where it gets a little bit fun. We're going to mind this point. So we're going to bring these folds down so they land on this fold. Do you guys see that fold, this one in the middle? So we need this line to fall on itself. This line, we need it to fall on itself. So they're on my right and now on my left. Now be aware that, we are folding several layers here. So like there, and now there's two layers here. We only need the top one. We can leave the other one folded there. You can actually fold that one to the other side. And here, this one, I'm matching to the one that we just folded in. So now this one is the second reference. So the fold I'm doing is making so the corner of it lands on the line, right? So they're on one side. And notice how they are having the same point. So I'm keeping an eye out for where this fold ends, right? They have a mutual point. So it's almost like it hits and then bounces back. I'm going to mount and fold these back so they're not getting in the way, in a way. Now from here, I'm going to take my vertex and notice like all the layer underneath. Like there's so much stuff underneath, but we're going to do it only for the top. So here. Do it for one, unfold, and do it for the other. Now, of course, if you wanted to have it be on the other side as well, you can just leave that folded in and turn it over and fold that using the edge as a reference. Here, so just to be clear, I'm on the back side using this edge as a reference there.
Which edge?
So the folded edge. So the one that I fold it and then I turn it over and I just copy that same thing on the back. And then you can take like the little legs that are there, you can just fold them up like that as well. Okay, last step. So from here, we can unfold. By the way, if you're more of an origami person, you can actually do some reverse folds on these, inside reverse fold on these. So what that means is that you could, in theory, you could open this up and you can actually sink these. You don't need to, but it's a fun little thing to do if you're more of an origami person. And you can have these sunk like that. Completely optional. But it looks cool, definitely looks cool. And so anyway, we actually need that, so let me unfold that. So we're here back at the Superman shape. Now I'm going to take this edge of the unfold right there. I'm going to put it on the opposite edge. So simply just take, now this is the harder part because of how many layers this has, but it's okay. It's all good. You try to hold it together. You try to hold it so that it's not diverting or too much, you know, not too many inaccuracies. And there you go. One, and then the other one. So notice how I'm sort of, I do the fold and with my left hand here, my fingers, I sort of push, I push down on the table, but I also slide so that when I do the fold, there's no crumple here, or at least to reduce the crumple, I use my finger there. So I try to use my finger here, my forefinger to push so that it's as, you know, as much as accurate as I can make it. So that all the layers are sort of doing the same thing at the same time and some of them are not like trying to get away or whatever. And then I open it up. We don't need to unfold. We don't need to follow the steps here. We can actually trace the pattern on one side of these. So I'm going to take out my pen. Where's my pen? I don't know where my pen is. So I'm going to use this colored pencil. So first off, I'm going to write in both pentagons. So here's one pentagon. It goes off into the other. One pentagon, two pentagon, and actually this pentagon goes and hits the other one. And this one also goes off, and this one also goes off. If you want to cut it out, this is the moment to cut it out. If you want to cut it out, what you got to do is you got to offset it. So what that means is that you sort of pick a distance. In this pattern in particular, the distance is sort of where, it's hard to imagine it, but you gotta like picture. Here's what you gotta picture. You gotta picture the line where this vertex on the top of the pentagon lines up with its middle. So it's midpoint. You gotta sort of picture the line that it goes from the center to this. You gotta picture that. And so where that line hits on the edge right there, can you see that line that I'm drawing in? So from the line that hits, then that's the line that then it bounces off of. So from that line, it draws a parallel to this blue line that I drew in. And then a parallel to the blue line down, and then a parallel to the blue line up. And then from there, a parallel line to the blue line down. And this is just like, you know, an eyeball kind of thing, but you can also make it be accurate if you wanted to by, well, you can get a ruler, you can like establish a distance, you can do a compass and actually line up these points, because from here, it's just like, you know, a radius you can actually establish, because we also need the same thing for the other side. So it's not like we do it on one side, we do it on both sides. So I do it on to the right of my blue line, but also need to do it on the left. And I need to have it be approximately the same distance. Like these two distances from the blue line need to be approximately the same. So there, and then the blue line here to my right. And also, so when you draw these in, you want to make sure also that these kind of like follow off into the next one. So for instance, this, I want it to be on the same sort of imaginary line as this one, so that it looks like it's part of the same like width, you know? Like this line needs to line up with that one in a way. So you can actually like follow through on these, but you only need where they intersect with the other one. So I can, you know, I can ignore this part of the sequences, because I draw this in just to be sure that they're on the same line in a way. Although not really, because this is just eyeballing, but. This is the one that I usually forget. This one on the outside of these little points. So yeah, I have my blue line there. You can barely see it, but there's the blue line. And so to my right and to my left, there's lines. I can use a little more space on this one. And so this is what we cut out. We cut out the pentagon, we cut out this little shape. Before I cut it out, I want to open it up just to show you that the pattern is there. We can cut it out, of course, but just to show you. And actually, as you can see, we are actually missing this line. Well, I am missing it. Let's see why I'm missing it. I don't think I'm missing it on the other side. No, on the other side, I have it. I don't know. Maybe I didn't fold that. Oh, yeah. Yeah, I should have it, but here we go. There it is. And pretty much, there you have it as the full pattern, just the folds. But what I'm going to do next is I'm going to actually refold it and focus on this. I'm going to cut out these shapes just to have then the extract of it. It's also fun to draw it out because then when you refold it, you can sort of picture like, oh, damn, like they are like all in the same wavelength in a way, like they're all matching. Like, once they're drawn in, you can like unfold and see like, oh, damn, like that line is the same line as this, and that line is the same line as that, and like it's all there. My favorite one is this line. That's my favorite line. Because when you unfold it, it actually comes in, like it's hard to see how this line on the bottom of this base shape is the same as this line. You know what I mean? It's a fun thing. So anyway, I'm gonna get on my cutting board and cut it out. Yeah, the green from the cutting board really like burns the image. I do have a ruler, maybe I should use it. I don't usually use rulers for the cutout, I just go by hand, but it really makes the effort a little less considerable when you use a ruler. So if you don't use a ruler, you have to really hold it in with your fingers, with your hands. So it's easier when you use a ruler because you don't need to use that much strength to hold it down. And because of the layers, you might also need to, go several times. Now, personally, I'm doing these and I'm making several of them. And I do want to do like a little thing on my windowsill to just like really cover the whole window with these, having them side by side and all. Now, of course, the more you make, the more you can also like appreciate the way that they come together. So that was also the point of the last diagram on the shape, how you can like take 4 of these or just 2 and cut them in strategic ways and then get a rectangular tiling. And then that rectangular tiling you can trace onto something else, or you can go wild on it. But once you have the rectangular tiling, it becomes more tessellatable in a way, It's not more tessellatable, but it is a little more elegant. A little more, because it ends up being inside of a rectangle instead of being inside of a rhomb. So you can also, divert the audience away from your base shape, because they're going to look at it and say, oh, it's a rectangle, right? But you know that it's not. It's really a rhomb. Yeah, ruler ends up being too much work. I'm going to pause the recording because who really wants to see this? Oh, wait, I'm reading the comment here by Marius. It says, I have more general question about them having faith you mentioned earlier. I'm still feeling I don't quite have faith. Is it, for example, possible that the paper curves when I stand in line if I'm not careful and keep it tight the whole time as the paper having? Yes, that is a thing that happens actually. Especially the bigger your paper is, the more that of the paper fold, like curving is bound to happen. So as much as fade actually is like part of the picture or whatever, like you do need to have some awareness as to how you can, or some reference as to how you can, just verify your things. So for instance, in the case for the initial rectangle, it's not enough to have fade because that's like the longest line we fold. So what I do in that case is actually make sure that on the other side, it's matching so that both lines are perpendicular. Yep. And there you have it. Yeah, it is real. So usually this design is weaved in this way that these shapes seem to be independent of each other or just like barely touching. This is usually the way that they weave it. It also like is very pleasant to look at. It almost looks like a cartoon. And actually, if you draw in the weave on this, like if you draw, like the line that connects these and such, if you actually weave it, it'll look even more like a cartoon, which is actually pretty fun. How you guys got along with this? You guys get it all right? Pause the recording once more and I'll put in the... So last bit of information regarding this design. Once you get it, if you want to make it look more 3D and whatnot, what you do is you make all the pattern lines be the same state. So in this case would be here my blue lines, I make them all mountain. And then I also make a valley that goes between them like this. So I use my nails in to really drive it in and just make a little, like a little cross there. Like that. So that actually will liven it up a lot more and give it that way more of a 3D look. Even though it's a flat piece of paper, this will actually make it stand out a little bit and be able to interact by folds a lot more. You can see how sort of I'm putting these together. And so because they're getting together, what it's actually happening is that these, they begin to like actually fold into a structure that looks very cellular in nature. Anyway, I'm going to leave that as an exercise for the viewer. It's a fun thing to do. Actually, this is one of the more hypnotizing aspects of this whole thing. And the advantage is that because we've actually have all these pattern lines folded in, it's just a matter of redirecting and putting them in the right order and just like them squeezing and finding where these actually like, compress and contract to have it be like this. So a fun little exercise. And it also makes it look way more 3D. So also if you want to have actually be a flat thing that you want to put on your wall, you might want to avoid this because it will make it like stand out way more. So it's not easy then to make it like flat, but it's still a fun thing to do. I mean, give it a try. See how it goes for you. All righty. So now we're going to move on to the tessellation portion. So for this one, we only have a CP, a crease pattern. All right. So first things first, we need to get the grid. Now the grid is not simply just keep folding the triangles. We're actually going to install some thirds into it, right? So here's how it's going to start. I'm going to fold my rectangle here in half. Now the example that I showed you, this one, is a grid of 24. Like it's in 24 divisions. I think it's 24 divisions. But for the one we're going to do in this example, we're only going to do it in 12. I think maybe we're just going to go to 6. We'll see how big we want our grid to be, how much resolution we need. But of course, the more resolution, the cooler it looks. So we start by folding it in half like this. Unfold, open up. By the way, I know that sometimes I go a little bit too fast. If you guys, if you want me to slow down, be sure to let me know in the comments or just shout out, whatever. I'll gladly slow down for you guys. It's no worries. All right, so we start with that division of the rectangle thing. We then take this unit, like the whole short angle of this thing, no, not angle, so the short edge, and place it on the fold coming in from one corner. This will give us the pi over 3 angle. This is how you construct that one. You can even see that sort of a equilateral triangle is happening there already. It's actually also a way to trisect the right angle, this method. You can see if we do another fold on this line, we'll get 1, 2, and 3 divisions, but not there yet. We're actually going to use this right angle there, because that's right angle. I'm going to use it to do a fold. So I'm going to turn it over. I can see there on the back a little bit, you can see where it is, but also you can just take the remainder and put that on the fold. And now, so this is the second fold we've done, right? I'm going to unfold the first just because it's easier to see. Unfold the first. And now I'm going to do a fold at this second point. So where the second fold we did hits the edge, we're going to do a perpendicular line. So I'm going to lift this. I'm going to start to drag it. And I'm going to drag it until it hits. And then I'm going to pivot and make sure that this lines up. This edge lines up to that other edge. And you're actually going to see that this corner that I'm folding lands also on the fold line in the center. So it should look a little bit like that. Of course, this rectangle might be different for you depending on which rectangle you start with, but you should be able to get this far into the rectangle. Some people refer to this as the bronze rectangle, and that's not entirely correct. The bronze rectangle is something else entirely. That's like a metallic ratio thing. No, actually, I don't think this rectangle has a name per se. This is just a √3 rectangle. That's how I call it. Because if the long edge here is unit length, then this would be √3 over 2. So if this is 2, so this is 1 and 2, so 2 units, like literally 2, the value of this long, the value of this height is √3. So that's this rectangle. So we're going to cut this itty bit that we folded in, this itty bit, going to cut it away. Everybody good so far? So in this case, I just used, just a single do-over on the fold, and that seemed to be enough for me to rip it out. So now we're going to repeat like this fold and do the same thing, but on the other edge. So in this case, we're matching the bottom to the fold line. And actually, you're going to see how they match, right? So same thing as this, but we're now do it on the other side. So then this matches to there, same point. And I can then unfold and repeat on the other side. All right, so now I'm going to teach you how to get thirds in this rectangle or in this reference. It's actually quite interesting. Because, you know, it's 3, so 3 and thirds actually have a very natural arrangement that they come together. All right, so we're going to take the bottom vertex and we're going to put that on this point. So from here to there. And then same thing on the other side. 1 and 2. Should look a little something like that. Okay. We can do it on the other side as well, but we're going to just do it on one side for now. We're going to do it later. So now we're going to take this point and put it on there, and then the other and put it on this one. We can turn it over. Sometimes I have an easier time just looking at the mountains than I do have looking at the valleys. So here I'm putting that point on that one. Of course, the advantage of doing it on the other side was that, you know, it would match also on the other side as well. So as much as it's matching here, it would match on the other two. So as you can see, that reference got us 1, 2, and 3. And because of the center, we actually have this one divided in half already. So if we wanted to, we can make 6 pretty fast, just dividing these in half again, and so we get 6. But before we do that, we want to make the grid be in thirds, like completely in a way. So at these intersections, we want to keep this going. You know what I mean? Like we want to keep this grid almost, like these references for triangles, like this triangle, be completely all over the place. If that makes sense. So we could do some bounces on this if we wanted to, or just keep in mind where it hits and then just folding the next line. It might be worth doing some bounces on this thing. Let's see. Well, there's 3 set of lines that we care about for right now. It's going to be this one, and that one. So all lines need to be parallel to these. So the second one, as you can see, has my vertex landing on this line. Hitting on the first. And then same thing on the other side. what I'm doing is I'm sort of crimping or pleating rather, just to copy this information and now put it on the other side. So pretty much it's like doing this grid for now. We're gonna do this grid first and then the other side. And just gonna extend on those in order to have well, we're gonna go all the way up to 12 in order to have enough information to relay several of those phenomena. Again, the more grids we have, the more complicated and cool it's gonna look, but also the more work we're gonna have to put into it. So I'm gonna show you how to get it on these, or at least how I would get it. And then you can try it on your own. So I'm just pleating right now, just going like mountain, valley, because it's easier, but actually all of these need to be in the same state once we're done. So this is just for reference. So keep that in mind that all the folds we're doing right now are gonna have to be interchanged into the same. All of these folds have to be the same state. Alrighty. How you guys doing? I know that maybe I'm going a little bit too fast on this one, but this is the objective right now. I went full in on the sixes, by the way. So you can see just a bunch of triangles pretty much. This is what we're trying to get. So it's 3 lines, 3 sets of parallel lines. It's one set going this way, second set going this way, and then third set is just going that way. So 1, 2, and 3. Now, this is not enough information to get really a cool effect on this thing. So we need to divide in half once more. So the way I count it off is how many divisions I have on this edge. So I have 1, 2, 3, 4, 5, and 6. On the long edge, I would have, they're not the same value though. Like this is just a division on the root 3s and this is division on the units. But it's also going to be 6. 1, 2, 3, 4, 5, and 6. So interesting to think about that same amount of root 3s and same amount of units. So we're in 6 and we got to take it to 12. So the way I usually do that division in half is I fold all my lines in the same state. The lines I want to divide in half. So all of them I'm putting them into mountains. So once they're all mountains, what I do is I just match them. So it's like I take one mountain and then put it on the other mountain. And then I take the other mountain and put it on the next. I take this mountain and put it on that one. So trying to get creative on how you do these because there are several ways to achieve exactly the same result. So whatever works best for you, I think that's the way to go. So for me, sometimes what I like to do is I like to fold these and like take it up like one and then just the same pleat and go it the other way. Sometimes, other times it's just better to like do it like an accordion. Just everything sort of collapsing toward the same. Now again, reminder, once we're done with these, we have to change the folds into them being the same state. Like all of these have to be the same thing. Once we're done, we're doing them in different just because it's easier to get the lines this way, but you know, down the line. And there's my accordion shape on one set of parallel lines, and now that's split into 12. I gotta go the other way. It might be better to do one at a time, perhaps. Like do one, and then you unfold, you take the other, and fold. Maybe? I don't know. Alternative method. Instead of pleating, like having everything be on the same, just like do one at a time. One, and then next one. Now, me personally, I like to have an odd number in my divisions, whether it be 3 or 5 or something. But I think it's more fun when you're not just folding in half and folding in half. I think it just makes it more interesting. In my experience, it actually can result in different arrangements being possible and evident because of the structure. So even though that, you know, if you divide this thing into just half and half and half, you might get eventually to like 16 or 32. And inside of those 32, you would have divisions of 10. Let's just say, like, you know, of 5 in there. But because you have those extra or those divisions in half, it just blinds you to the possibilities within the 5 division. So I don't know, that's just my experience with folding these. And that also happens in the square. And I guess with anything really. I mean, maybe that's just the general case for these 2 particular ideal shapes, right? So I have 2 sets down. Last set. So I hope that you're meditating as you fold these things, or just like keeping thoughts in your mind, or juggling whatever thing is happening inside of you. That's good. So my sets are done. So what I'm going to do next is change everything into the same state. I'm going to choose valleys. So everything I have here needs to be valley. So just whatever mountains I have need to change. Alrighty. So I'm gonna wait a couple minutes for you guys. I'm gonna pause the recording a little bit. And so we resume. So here's what's next. We need to include now. So we have all these pleats and I have them all here in value. So that's all well and good. So now I'm gonna add in my mountains. Now my mountain is gonna be another set of 3 lines. We're not gonna get as many though. So I'm gonna turn it over. And here's how that's gonna work. I'm gonna find the hexagon that's inside the center almost. So that's gonna be like the seed I'm gonna base off. So in this case, it's gonna be this one. You guys see the hexagon that I'm selecting? Okay. So the mountains that I want to get are gonna go like across, like this mountain here, this there, and then this. I'm gonna actually drive it in a little bit more. So it's there, there, and there. And so they need to be opposite of whatever it is I had on the back. So I have them all here in valley form. So these on the other side are going to be valleys, right? Because on this side, my valleys are mountains, right? Does that make sense? Okay, so I'm going to inscribe these 3 first. Now I'm making sure that I'm going through them, of course, by just noting where my point is and making sure that it crosses over on all my points on the back here. And then 1, and 2, and 3, and boom. So I make sure that these are touching. So they're all lining up. And so also on the bottom, I make sure that all these points are on the fold. So it's going through my line that I selected. Yes, both. It will be recorded and it will be emailed to all the people who signed up for this session. And will be uploaded to Patreon and all those other things. And it will go on YouTube. Like, well, it goes on YouTube for the recording, but it will be made public in a way in about, a couple weeks. I say a month, but sometimes I think that's a little bit too long. And then my 3rd line here. And so these are going to be my 3 sets of lines. So rather, these are going to be the same sort of idea, right? So on these lines, each of them is going to have a set of parallels. But it's not going to be on every single division. It's actually going to jump a unit. So you guys see this rhomb? So the next line is going to be after the rhomb, not inside of it, after. So the next line is going to be here. A rhomb of distance apart. So then the next one is going to be here. And then the one after that is going to be here. And after that is going to be here. And after that, and so on and so on. And for these, the same. So you can just look for a rhomb length and then put another line after that rhomb. And a rhomb length and another line. Rhomb length and another line. Rhomb length and another line. Pretty much. So what you can do is you can select the points, be aware of what point that is. In my case, it's going to be like that point. And then I fold up and I kind of don't lose the point. Also, you can then see how many units when you fold are going to be apart. So for instance, in this case, the one next to it is on the edge, right? It's because it's going to be the half. And the next one I fold, I can count off how many part it is. So it's like a whole hexagon. Does that make sense? So I'm folding it in half first. And then the next one that I folded, I notice that it's a hexagon apart when I fold it. So it's like 2 rhombs in a way. So then the next fold, we're going to be a hexagon apart from there. So here. So I don't even have to look for points no more. I can just like count off my distance. So I went 1, 2, and then that's a fold. And just make sure that all the points are lining up. And by that, I mean that all of these points are touching their respective coincidences. And so I'm 2 units, so 1, 2, and then after that, another one. So there. And after this hexagon, another hexagon. And after this hexagon, another one. Now, as you can see, that's solved for half of this. You can see how they're, evenly apart and they have a rhomb between. So now same thing on the other side. So my hexagon distance, I fold, count off my next hexagon. Then the hexagon after that. Another. And last one. Now, same deal, but on these. So in my case, I'm finished with these verticals. Now I need to get these. So first one that I have lands here, and therefore it's going to be like this amount, right? Because it's going to be a hexagon here too. So that means the fold is going to land here. Another hexagon. One, two, and three. One, two, three, four. One, two, three, four, five, six. And I think that this little bit also. It's a great exercise to just keep an eye out for things, right? Again, it's like now on this line. So 1, 2, 3, 4, 5, 6, and 7 itty bits. Now, in a way, this circuit could be, an infinite amount of things. You can do all sorts of different arrangements and find all kinds of different, tessellations or corrugations or whatever is your fancy. But today we're going to do that CP one that I sent you. And so once that we have this finished up, this pleating business with these 6 sets of parallel lines, 3 sets are in one state and 3 sets are in another. And so that's necessary because that's pretty much how it is. Marius, thank you for being around. Hope you enjoyed it. So I'm going to turn the paper over to the first set of lines that I ended up putting in a valley. Now you might notice that we have hexagons with their lines of symmetry divided, and then we have triangles with the lines of symmetry inside. So, we could trace a tiling of a 6-3-6-3. That means that hexagon, triangle, hexagon, triangle. Hexagon, triangle, hexagon, but we're not. So in this one, you need to pull up the CP that I sent you on your email. That's going to help us just find it a little bit better here. And so what we're going to do is we're going to trace the black lines first. So I'm going to trace a hexagon on where the hexagons are valleys. And this is going to help us enormously. So I'm going to trace the center hexagon. Can you guys see that okay? Center hexagon, and then I'm going to choose a direction for this thing. So I'm going to go like in the instructions, and then go 2 units. You see how it goes 2 units off? So this is 1, 2, and 3. This one also goes 1, 2, 3. I'm counting off also the line of the hexagon. So it goes 2 after the hexagon, but we can count this as part of it. Right? And so what we want to do is then find the shape that this whole thing revolves around. And so the way this works is that it has then, you can see that it's sort of wanting to be a triangle, but then this one cuts off there. And then from here it goes 2 out, 2 top. Actually it goes 3 top. So this is the shape we want to get. And as you can see, it has like a little triangle there in between these. So it's like these triangles share this mutual one. These 2 triangles are like merged, and they have this little guy in common. Pretty much, that's what's happening. And so we find the rest of them. We got to look for them now. So here's the other merge. I can see that it sort of comes in, and then that point is like a mutual one for those. So boom, hits. This is a 3. Hits on there. That's also a point of contact for these. I feel that once you get the idea for the feel for the shape, then it becomes a little more evident, I feel. Correct me if I'm wrong though. What do you guys think? You don't have the feel? Yeah, I know what you mean though, but this is the first step. It looks like a little radioactive symbol, kind of. So there's two orientations to the shape. It's not the same shape. Is it though? No. So these are like mirrored, right? So these two shapes are the same shape, but one's facing like down in a way, and this one's facing up. You can see that it has this one has the hole, if you will, on the bottom, and this one has it on the top. But same shape. So the way I count it out is like 3, and then 2, 2, 3, 2, 2, 3, 2, 2. Yeah, no hurry, no hurry, you guys. We're doing great. Now, if we only folded 6, we wouldn't get to see this actually happen, because in 6 we would be limited. I don't think we would have these centers, for example. I mean, we could make it happen, but it would be very limited. Like in this case, we only barely get to see a hexagon with a full sequence around it. Okay, so here's where the fun part begins. So we've done all of the hard work. This is the ground, this is the foundation. Now we're going to build on it. So we want to keep in mind our hexagons. And what we want, first and foremost, is to activate this. If you want like to have some more work to do, which I don't really strictly recommend or not, depends on where you want to take it, but you can write in your mountains if you want to. I mean, I think it's pretty obvious. We're going to use these and then go like down here, and then this is going to bounce off and hit here and there. I think this is evident, right? Because that's sort of like the only place it can go. But if you want to inscribe them, go ahead. But I think that with the shapes that we have, I think that's enough. That's just me. So what I do is first, well, I need to like activate. I call it activating, but it requires some pinching, some moving. So here what I'm doing is putting my forefinger and thumb aside from the line of the mountain that I want to activate. And I'm with my other hand, I'm pressing around, and so I activate this move. You see how this lines up this face? And then that's one, and then I go for the other. And so what I want is for these to be activated like such. And so as I'm pressing these, I'm going on the other side. So no need to stress out, breathe. The paper will not do anything that you are not making it do. So if you like, notice that I'm crumpling and it's all like all over the place. Doesn't matter. I don't need to get excited here. All I need is to just see where my lines are. For instance, there, just put it into position. position, and just, just squeeze and touch and just put it into a mold that I can crumple. So I want to get these islands to come alive like that. Now, the pattern itself will not be really in your power until all of these islands are set up in this way. Until then, we're just really just moving things around. But once these islands are set up, it's just like magic. It really is one of those, it's amazing how origami works. It needs to line up more than you think for it to like properly do what we need it to do. If it weren't for the thirds that we inscribe into this, it wouldn't be as ideal. Some things would be off, like off the edges, and it wouldn't be as nice. And I think that's also interesting, the fact that when I discovered this, I was using a grid that had threes, like this, just like this one. Actually, I think it was exactly this amount of divisions that I had when I discovered this. And so it's my point that because I had that amount was that this pattern was able to shine for me. At least that's my belief, right? So again, as I'm activating these islands, I call these islands, by the way. I just check that the necessary information is in, and then I move on to the next. And remember, I won't be able to actually make it properly work with power until all of these are set up. And just like a little, like just with your finger, just like sliding in and touching, you're going to see how the smallest amount of pressure will make a difference. You don't need to push it really hard. You don't need to like, you don't need to be overexertive with your power, with your dominance over the paper. Just press and push and pull, like very strategically, very softly, and then it'll do what you need it to do. Just keep your eyes open. This is one of those things that I make sound easy. And I'm aware. So one of the benefits, at least for me, with these online classes was that back in the day when it was like, in person, I had this really bad habit of sometimes when the student was really having trouble, I would take it away from them, like, here, let me show you, and do it on theirs. And then I would undo it and give it back to them, me thinking that would be enough, right? And, whether you like it or not, that kind of demotivates the student a little bit sometimes. Not always. Sometimes they'll be like, oh, okay, I see what you mean. But other times they'll go like, well, why don't you just do it? And some kids, especially the kids, will be like, they'll just give it to you. You do it, because they're just like fed up and they see that you're willing to do the work for them, and they'll be like, oh, you're gonna do work for me? Then go ahead, here's my work, do it. With online, I can't reach over the screen and just take the paper from you and just go like, here. I can just really do it for myself. So in terms of my teaching, I think that in a way this has been really helpful, and I hope that this lesson carries over if we go back to the way things kind of were. Maybe, hopefully, maybe not, maybe, I don't know. We'll see. But it is interesting how there are some things that just simply cannot be taken away, like robbed, I want to say. Like, you got to do it for yourself is what I'm trying to mean. So I'm trying to get at. And there's really just no escape from that fact. But that's nice. It carries off into many areas, and in the end, it makes the person feel like they accomplished something. It's the reason why video games have like little songs when you do something right. They have to really drive the point across that you did it. Give you some feedback. Okay, so I'm gonna wait here. I pretty much have my islands already set up. But there's one more step that sort of needs some tinkering. So I'm gonna wait for you guys. So me personally, I like my style of tessellations, I feel, are ones that require several steps. So there will be some lines to get to the shape, and sometimes they're pretty complicated. Like I think this is fairly complicated in a sense. And it's easy, it's simple, kind of, but at the same time, not so much. But this is the preliminary stage of this tessellation. By itself, it's a corrugation, but now we're gonna activate or do something into it that will allow us to just make it really pop. If I turn it over, looks really nice. Some shadows happening, but it's not really mechanical yet. It's not moving. It's not doing anything exciting yet. And what I really love about these shapes, I mean, when they're folding and when they have the pencil lines drawn in, they look like cartoons. They don't look real, especially on camera. Okay, so not everybody's got it, but I think the general idea is kind of there, and maybe the recording will help. I hope that you enjoy this because I particularly enjoy it so much. Here's what you do. These little islands, they need to connect. These three lines need to be on the same. So that means like these three, you got to push them and you got to choose the direction. They're going to spin. So it's like they come together and then they spin. Now this ain't easy, but once they do, they're gonna look a little bit like that. And you can even press them a little bit and get them to be looking like that. So it's like you push them and then you twist them. And then you can like, you know, pop it a little bit and get it to be like that. You can add another fold in there to just make sure that this happens, but it's not strictly necessary since what we care about is just the other side of it. You can see also the way that I'm sort of pushing these islands together. And then once they come into contact, they kind of twist and then they can lay flat in a way. So this is what I meant by tessellations with several steps, because this one requires first the islands and then requires this little twist.
Are we creating a belly fold during this thing? Around this?
Yes, there is a fold that little. Can you see that little guy there? That sort of becomes a valley, yes. This pressing of them is optional, but it does give it some more stability. And yeah, I mean, this is an ambitious project. I gotta admit. So if you guys are getting it, you know, congratulations. If you're not getting it, don't feel bad. You can always try again, and you can always, you know, come back to it later. There's, you know, as long if you don't do anything to it, nothing's gonna happen to it. So you can always just lay it down, take a breather, move your fingers around a little bit if they get cramped. You know, come back at a later time. And once all of these are set up, and which is my case, like they're all twisted now. I can turn it over. And there I see the effect now in position. So now when I call this the locked twist because it's sort of like the hexagon is twisting. It's not a complete twist, it seems. Like it has some space around it, but at least it's weird. Like I like how it looks. That there's a hexagon there and a hexagon inside, and then sort of goes off. Has the islands are sort of shrunken together. So it's kind of wild. I gotta admit. Which side do you like better though? This side or the other side? Me personally, I think I like this side a little bit better. And if you're feeling super ambitious, you can divide the grid in half once more. Oh shit. This tripod is killing me. You can divide the grid in half once more and get to there. So this is like 1/2 more division. So if this was 12, then this is 24. So you can see that considerably many more little islands are happening here. But it looks way cooler in a way. It just has that much more resolution, but it's way more difficult to put these into position and have them twist the way you need them to. And actually some of them I couldn't even like make pop. Like these, they just look like little twists, and that's fine. That serves their purpose. And of course, the more resolution it has, the less it matters. Because the less you notice it, the more it just looks like the mechanism. In a way, you kind of just get lost in all that definition. And something you can do, noticing that you have half a hexagon here and half a hexagon there, you can do this several times and put it together with sticky tape. Like literally just put sticky tape from one to the other and then begin to activate it. And you could really just have the thing work as a whole single piece of paper. So that's a way that you can combine these and make a bigger thing if you don't want to go for the single paper approach. Just an idea. So I don't know, you guys are heroes, man. You guys are heroes because you've been here for 3 hours almost. You've been folding, you've been trying, you've explored some things regarding yourself, the paper. And we folded a 5-fold, we folded a tessellation on 6. And I hope the instructions makes it a little bit clear. I know these are difficult, especially this one might be a little bit too difficult, but it's fun. I like to think. And it's a great, oh, there you go. Oh, Shashi just made a flag completely, like just nice. I hadn't thought about it like that. Like you completely flattened this, didn't you? That's interesting. That's interesting. I hadn't thought about it like that because you could. I mean, you could just, well, maybe, I don't know. Because the way I figured was that this fold coming in kind of like made it difficult to completely squash it. I guess. Yeah, I don't know how to do it. Interesting. I'm gonna look into it.
I twisted it. I didn't see your spread this thing.
Yeah, just a little bit.
Spread squash you did, no?
Yeah, but just a bit.
I'm just noticing it. I just twisted it.
Okay, just like completely like, and that works fine too. That works fine because at the end of the day, what you want, this is like the backside of it, really. This is what you're looking for. So you just want to have like these. I call it a locked twist. It's like a partial twisting kind of, yeah. Oh.
Thank you.
No, thank you, Shashi. Thank you, everybody, for joining us today. Hope you had a good time.
Yeah, bye.
Enjoyed it. And I'm going to pause the recording. I'm going to start the recording, rather. Thank you all for joining. And if you want to have a little discussion right now, we can do that. And so, yeah, thank you guys for the recording. Right on. Hope you enjoyed it. Bye, everybody.